Let's look at the electrical field produced by a ring of charges at a point on the axis of the ring. What it means is you have a line that is passing through the center, and by the way, this is a ring, and we have the center O. Through the center and perpendicular to the surface, we have a line passing through. This is your axial line, and we have a point P at some random point, that is, but on the line. Now we are trying to figure out what is the electrical field at this point because of this ring. So we're starting the derivation with, we're considering a ring R, sorry, radius A, with radius A, not R. Let the total charge, so here the charge is fixed. So the entire ring has a charge of Q. Let point P be x units away. So this is x units away from the ring along the axis of the ring. And also the charge distribution is uniform with charge density lambda. Okay guys, so let's call this as dq. Don't have space over here. Okay, we'll call this as dq. So dq will be equal to lambda dl. So basically this small length is dl. Okay, so this is the entire picture. Now first thing first, what will we do? We'll look at how the dE, right, how the dE is. So how will we do that? By drawing a free body diagram of a unit charge at P. So now we are looking at dE, and we'll call this as theta, right? So if this is our horizontal line, this will be theta. Now, what is that we generally do? We resolve it. So if I resolve it, this will be dE, yes, cos theta. Is that correct? That's correct. And this is dE sin theta. Let's call this as, and it is actually parallel to axis, and this is perpendicular to axis. Agree? Now, let's look at the free body diagram of the same unit charge. At P itself. But now it is because of two charge segments which are diagonally opposite. Is that correct? What I mean is, here we have dq, right? Diagonally opposite over here is this dq. If I consider dl, so if I draw a diameter, this will be your diagonally opposite dq. If I consider over here, draw a diameter, this will be your diagonally opposite length or charge. Now, what is the point of that? What will happen? Can you guys pause and draw? Did you try? You guys should be trying all of this. So we have a line parallel and perpendicular to the axis. And say we have DE, DE, and we have the set of components. So clearly this is DE, this is theta, so cos theta, and we'll have again DE cos theta. So basically the parallel components are adding up while our DE sin theta will cancel the DE sin theta. So from the diagram, what can we conclude? We can conclude that the effective or the net field is because of parallel component. So basically we have E is equal to integration of dE cos theta, right? And on opening up dE, we have 1 by 4 pi epsilon naught, and we have dq by L square cos theta. Agree? Now, here what and all are constant. What will remain constant in this diagram? So the same sequence of things. There's no change. Of course, radius will not change. X will not change. Will theta change? Nope, even theta will not change. So basically, the length has to be added from one end to the other end. We just need to know about the correct limits. So basically, if I take out the constant terms, so we have 1 by 4 pi epsilon naught, even L, sorry, I didn't tell what is L. L is your distance from dq to point P, that's your L. Even L is constant. Agree, if I, whatever point I take, because a square and x square is constant, L has to be constant. Pythagoras theorem. So even L is constant, cos theta is constant, L. And so we are just integrating dq, which we can write it as lambda dl. The length dl, right? The length dl, if this is a starting point, say this is a starting point. So starting point is 0. If I have to go one round and I have to come back, so this will be 2 pi a. Why is that? Correct. Circumference, is it not? So the limit, we need to add dl from 0 to 2 pi a, as reason being we are to add the entire circumference. So basically I am walking from the starting point and coming back to the starting point. So the length that we will cover is 0 to 2 pi a. Agree? So here lambda is fixed, 4 pi epsilon naught is constant, cos theta is constant, L is constant. So basically this length L, integration of dl is that 0 to 2 pi a. We need to integrate in this manner. So basically lambda by 4 pi epsilon naught cos theta by L, this is 2 pi a. All looks good, but we need to express in terms of one thing. Finally, expressing, actually this is an answer, this is also valid. but we need to express in terms of the radius a, the length x, and the charge q. What is this charge q? That's the total charge on the ring. Okay, guys. So first thing first, what else? What can we do? First thing is, I think we'll start off with lambda. Lambda is q by the entire length L. So lambda by L, sorry, not that L, the total length. Total length is what? Circumference, is it not? So that will be q by 2 pi a, or lambda into 2 pi a is q. Basically, this entire expression is q. Anyways, let's keep that. So therefore, q is equal to lambda by 2 pi a. So one term done. So this is done. This is done. Next is cos theta. So from diagram, let's go to the diagram. Cos theta is adjacent by L, x by L. Cos theta is x by L. So basically L into, okay, no, so that is so. Cos theta is x by L, there's nothing. So cos theta is taken care of. Then we need to express L also. We can't have L. That is simple again. From diagram and Pythagorean theorem. Sorry, this is L square, is it not? Yeah, I missed out L square. L square is equal to x square plus a square. Pythagorean theorem. Therefore, on substituting, what do we end up with? E is equal to, so lambda 2 pi a, I'm writing it as lambda 2 pi a, I'm writing it as q. Cos theta, I'm writing it as x by L. Again, L has to be substituted. 4 pi epsilon naught will not go anywhere. And L square is x square plus a square. And again, substituting for L, what will you get? Root of x square plus a square. So basically, we have q x by 4 pi epsilon naught. Let me write it this way. X square plus a square to the power of 3 by 2. I can write it as 1.5. And this is your final expression. Quite simple. It's much simpler than the infinite long length of wire, right? Now, one last thing. This is the last thing. It's quite simple again. If P or point P is far away, that is, we have x which is much greater than a. What will happen? So from this, we can infer that x square plus a square will be equal to x square itself, approximately. So therefore, what do we have? Q by 4 pi epsilon naught. So x by x cube. So this will result in 1 by 4 pi epsilon naught q by x square. What does this look like? Yes, this implies far away. Actually, don't write far away in exam. Write for x much greater than a. For, actually, I missed the word. For x much greater than a, the ring acts like a point charge. Does it make sense? When you look at a ring very far away, what happens? It looks like a dot. Any circle, if you look at it very far away, it looks like a dot. Like stars. right? There's huge rings, not exactly a ring sphere, but point is they look like a dot. And mathematically we got that. That's the fun part about maths, you can understand nature with bit of symbols and derivations and stuff. Now, what is the overview? Here too we went with looking at a diagram. Then we got a set of expressions, right? Basically we got DE perpendicular and DE parallel with help of our free body diagram. So once we have that perpendicular, parallel, and so on and so forth, we get to cancel and add things. When we got to cancel and add things, we ended up with parallel components and a simple bit of integration. But additionally here, in the last step, we expressed in terms of A, X, and what else? Q. Right? So this is the overview. Okay, guys, you can pause and copy it off.